The fastest way to lose with AI is picking the so-called best model.
Right, because there is no single best model. There are only models that fit a job well, badly, or expensively.
That sounds backwards to new programmers. They see rankings, benchmarks, giant context windows, and assume higher score means better choice.
Benchmarks matter, but shipping matters more. In practice, you judge a model on four things: quality, speed, cost, and reliability.
So, if I ignore one of those, I can still end up with a model that looks impressive and wrecks the product?
Exactly. Picture a customer support bot. If answers are brilliant but slow, users leave. If it is cheap but wrong, support tickets explode. If it is smart but inconsistent, trust dies.
Let's break that down. When you say quality, what are programmers actually measuring?
Quality means task success, not vibes. Does it summarize correctly, generate valid code, follow instructions, use the right tone, and avoid obvious mistakes on your actual workload?
So, not abstract intelligence. More like, can it do this job with acceptable failure rates?
Yes. A coding assistant and a data extraction tool need different kinds of quality. One needs reasoning and syntax accuracy, the other needs precision, consistency, and structured output.
Give me a concrete comparison.
Say, you are extracting invoice totals from messy PDFs. A giant general model may reason well, but a smaller model, fine-tuned for structured extraction, could be cheaper, faster, and more consistent. For that use case, smaller wins.
Now speed. New builders often treat latency like a nice-to-have until users start complaining.
Latency changes behavior. If a coding copilot replies in 1 second, developers stay in flow. At 8 seconds, they tab away. The same model can feel magical or broken based on response time.
And speed is not just user experience. It changes system design too, right?
Yes, slow models force queues, retries, caching, and awkward UX. Fast models let you do interactive tools, agent loops, and real-time moderation. Latency is product strategy, not just engineering trivia.
Then cost. This is where teams get blindsided, because a demo is cheap and production is not.
Exactly. You are not buying one answer. You are buying millions of tokens, repeated calls, retries, tool use, and maybe long context. A model that is 2% better but 10 times pricier can kill the business.
So the winner on day one can become the loser at scale.
Absolutely. Imagine an app generating study notes. At 1,000 users, premium quality may be worth it. At 1,000,000 users, cost per request becomes a survival question. Margins decide who stays in the market.
That brings us to reliability, which sounds boring until it blows up production.
Reliability is boring in the way breaks are boring. It means stable outputs, predictable formatting, low outage risk, steady latency, and behavior that does not swing wildly between similar prompts.
So, if I need JSON every time, a model that occasionally gets creative is not quirky. It is dangerous.
Correct. If your workflow depends on machine-readable output, one malformed response can break an automation chain. Reliability often beats peak quality when the model sits inside a larger system.
Give me one more scenario where that trade-off is obvious.
Think about fraud review. A highly capable model that occasionally invents facts is risky. A slightly weaker model that stays inside the evidence, returns strict fields, and behaves predictably may protect the business better.
So, if there is no best model, how should a programmer choose without drowning in comparisons?
Use a simple framework. First, define the job in one sentence. Second, rank the 4 criteria: quality, speed, cost, reliability. Third, test 3 candidate models on real examples, not toy prompts. Fourth, measure failures, not just average success. Fifth, choose the cheapest model that clears the bar.
I like that last part, because it sounds almost ruthless.
It should be. If 2 models both solve the problem, the cheaper or faster one often creates the advantage. Better economics means better product, faster iteration, and more room to improve.
And that is the power shift, right? Teams that pick models by use case move faster than teams chasing prestige.
Exactly. The winners are not the people with the fanciest model. They are the teams that match model behavior to user needs, system constraints, and business reality.
So the real question is not, which model is best?
It is, which model is best for this job, at this speed, at this cost, with this level of risk?